All right, 5, 5. More identities. This section is all about the double angle identities. Not going to take you through the development of it, just going to give you the double angle identities. So, sign first. I'm going to use theta. Sine of twice an angle. Algebraically, you'd probably think what? Take the sine of theta and double it. Doesn't work that way. Not algebraically. Here is what it actually expands into. 2 times the sine of theta. There's the part we were thinking.
Times the cosine.
Very good. Good guess.
Okay.
Okay. Tangent. We're doing all 3 today. Of a double angle. 2 tan of the angle over 1 minus tan squared. Tangent's always ugly. And then cosine. Cosine actually has 3 versions. Because it equals cosine squared minus sine squared. And because we've got those squareds in there, and we have a Pythagorean identity that has cosine squared and sine squared together, you can get a couple other versions of this. I could show you the substitution in the algebra. I think I'm just going to give them to you instead, just to save some time. So there's one version of it. Or it would simplify to 1 minus 2 sine squared of the angle. And the third version is 2 cosine squared minus 1. So cosine has 3 different options.
So
they all kind of
They all come out to be the same thing.
like we can name those 3.
Yes.
Cosine.
Just about. I'll show you when you can't, when you can't. When you can and when you can't. So, let's go with where do I want to start these notes? 1, 2. I think I'll start with the easy ones and finish with the hard ones again. How's that sound?
How many in here?
I got 1, 2, 3, well, 5. But 1 has some parts to it. Okay, let's go here. Okay, we want to simplify here. Two cosine squared of 15 degrees minus 1. Simplify or find exact value, whatever the case might be. Because I've got all numbers in here, I'm going to want to find an exact value for this. Okay, so exact value, you don't have 15 degrees on your circle sheet. But what identity is this? What has 2 times the cosine squared of an angle minus 1? Yes, it's right here. 2 cosine squared minus 1. That's actually equal to the cosine of double the angle. Let's see if I rewrite it that way if I find something that's on the circle sheet. Yes, you will. So how would I rewrite this? What would this simplify to? Cosine of double whatever the angle is. So it's the cosine of double what? 2 times 15. What's 2 times 15? Cosine of 30. Is that on your sheet?
Yeah.
What does it simplify to?
Just a moment. Square root of 3 over 2.
Very good. B. Yep. 2 sine of 22.5 degrees, cosine of 22.5 degrees. You don't have 22.5 on there, but does that look like one of the identities that's been expanded?
It does.
Which one is it? It's the sine one, so I can rewrite it as the sine of what?
It's,
Sine of 2 times 22.5.
Sine of double my theta. My theta is this 22.5, so it's the sine of 2 times 22.5. What's 22.5 doubled? 45. What's the sine of 45 degrees? Very good. So far, so good? Okay. If there's radians in here, what are you going to do with them? Change them to degrees, and it's just like this problem. So if it's the problem in the book starts in radians, kick them into degrees, and you do the same. Look for the identity that matches. All right. Find the exact value 2 ways, no calculator.
well, we already did that. Look at that.
Let's see, I better try that one in case I give you some. Find exact value in 2 ways. No calculator. Okay, so here's our first problem. I want the sine of 2 times 45 degrees. Done 2 ways. Okay, what's one way you can find this exact value?
Just take the sine of 90.
Yeah, you can multiply 2 times 45. So that will give me sine of 90. What's the sine of 90?
It's 1.
1. Okay, you found it one way. You multiplied 2 times 45. What's the other thing you can start with here? What's the other avenue you can go down?
2
The 2
times.
sine times.
Follow the identity for 2 theta. So I'm going to follow this identity right here. Sine of 2 theta, where my theta is a 45, equals 2 times the sine of 45 times the cosine of 45. So I'm just going to expand it. So it's 2 times the sine of 45 times the cosine of 45.
Is this the second way?
This is the second way.
So is that C or 1?
Nope. We're going to do one with a tangent in it. So it's 2. What's the sine of 45? Square root of 2 over 2. So I'm going to put that 2 as 2 over 1 sits next to the fraction. And what's the cosine of 45? Also square root of 2 over 2. Do I need a common denominator to multiply? No. So, I can cancel first, so I can cancel one of these 2's out. What's the square root of 2 times square root of 2? Square root of 4 is 2. Over 2 is 1. Well, got the same answer 2 different ways. I used the identity, and the first way I just simplified the angle. Yeah, first way was a lot better. Okay, one more of these, a part B, with a tangent. B. Okay, we got the tangent of 2 times a negative pi over 3. Okay, what are you going to do first? I would change it to degrees. So I'm not, this isn't actually one of my ways yet. 2 negative, what's pi over 3 in degrees? Negative how many degrees? So we'll cancel it with 1/3 of 180. 3 goes into 180. Negative 60 degrees. Do you have any negative angle measures on your sheet? No, you could move backwards if you wanted. Otherwise, how do I turn that into an equivalent positive value? Subtract it from 360 or add it to 360 in this case. So what's negative 60 plus 360?
300.
2 times 300. Are we good with that?
That's a big difference.
That's a big difference, yep, because negative 60 would be going around the other way, 300, land in the same spot.
Where did we get tan, or where did we get the negative 60 from here?
Converting radians to degrees, divide by pi times by 180. Okay, so we have not even started the problem. The goal said find this exact value 2 ways. So method 1, multiply them together. You're going to get the tangent of what? 600. Well, that's a little bit large. What's that equal to? Part 1, doing it one way.
240.
How'd you get 240?
600.
You subtract 360 till you get down to something that's on your circle sheet. So if I subtract 360, he said that's equal to the tangent of 240. Can you look that up? Square root of 3. Method 2, we're going to use the identity. We're going to start with the tangent of 2 times 300, which is where I started that first one, where this is my theta. If you look back at the identity, we're going to use this right here. I've got 2 times 300, 2 tangent of 300 over 1 minus tan squared of 300. So 2 tan of 300 over 1 minus tan squared of 300. All right, what's the tangent of 300? Negative square root of 3 over 1 minus a negative square root of 3 squared. Okay, so I get negative 2 square root of 3 over, oh, this one's going to be ugly. What are we going to, oh no, it's not going to be ugly.
Wait, what'd you, oh, never mind.
Good? Yep. What's the negative square root of 3 squared going to turn into? That's going to turn into 3. I'll have 1 minus 3 down here. What's 1 minus 3?
2.
Negative 2. Now what happens? And what are we left with? Which is what we wanted. So we got that answer 2 ways.
That's not bad.
Okay. Now the hard one. Find all 6. Really? Trig values of 2 theta if the cosine of theta equals 3/5 and the sine of theta is less than 0. Okay. So, what we are looking for, I don't like the way the directions are given in this book. I'm looking for all 6 trig values of 2 theta. So that means I am looking for the cosine of 2 theta, the sine of 2 theta, the tangent of 2 theta, the secant of 2 theta, the cosecant of 2 theta, and the cotangent of 2 theta. That's our goal, to find all 6 of those. Okay. And I only know something about theta, the single theta. So I'm going to use those identities that we wrote down. So, if I want to find the sine of 2 theta, I need to know two things. I need to know the sine of theta and the cosine of theta. Do I know both of those? No, I only know one of them. What am I going to need? Jesus. I need Jesus. Yes, I do. And when I get to tangent, I'm going to need to know tangent. If I know one ratio, how am I going to find all the other ones? Triangle. You need a triangle to get all the other ones. Okay, I need to sketch a triangle for theta. Only thing I wasn't as nice, I did not tell you which quadrant, but can you figure it out? Sine's negative, cosine's positive. Where's theta?
2 and 4.
2. Watch 2.
4. Sine's attached to the y value. Where's the y negative at? Down. So it's either 3 or 4. Where's cosine positive? Cosine's attached to x. 4. So we are in quadrant 4. So this is my angle theta. It's in quadrant 4. And I know the cosine is 3/5. What does that make my missing side? A -4. You don't even, you should be picking up on 3, 4, 5. Nice job, Austin. Cosine, I could have found the cosine one because there is an identity with just cosine in it. I could have gotten this one out of the way.
Oh, I thought the 2 by the 3.
Oh no, remember it's not just algebra. Remember?
Oh,
You're thinking algebraically, I just double it, but oh no.
I am.
Oh no, it's all this ugliness. Okay, so it doesn't matter which one I find first. I'm going to go with sine first. So if I find the sine of 2 theta first, my identity says, I'm going to write down the identity, take 2 times the sine of theta times the cosine of theta. 2 sine of theta, cosine of theta. I'm going to make that 2/1 because I know I've got fractions coming. What's the sine ratio?
-4/5.
-4/5. And what's the cosine ratio? 3/5. Looks like nothing will cancel, and it's okay to multiply. No common denominator needed. Numerator is going to be -24 over 25. So there's my sine ratio, -24 over 25. What other ratio do I know right now? The cosecant of that angle will be -25 over 24. Let's do cosine next. Okay, cosine, you have an option. It doesn't matter which one you use for cosine.
Which one do you think is easier?
They're all the same.
I think the top is the
They all suck.
Cosine squared minus sine squared, it doesn't matter to me. Cosine squared minus sine squared. It truly doesn't matter which one of those you grab. So the cosine ratio is 3/5, and we got to square it. The sine is -4/5. We've got to square that. So that makes 9/25 minus 16/25 for a final answer of
-7/25.
There's my cosine. -7/25, which makes secant. Okay, now when it comes to tangent, I'm going to be a little bit clever here.
Oh. Oh, hey, can't you just,
I didn't even.
7 over 24?
Oh, where's that coming from, Austin?
That is coming from cosine and sine. Tangent is equals, like, cosine over sine.
The other way around.
Sine, yeah.
Okay, we could go through this identity, or Austin is remembering, what's our fundamental identity that tangent equals? Tangent equals
Sine over cosine.
sine over cosine. I've already got the sine. I've already got the cosine. All I've got to do is divide them. sine over cosine. So I'm going to use this identity instead. The sine of the double angle divided by the cosine of the double angle. Just a little shortcut. So sine is negative 24 25ths divided by negative 7 25ths. And what little shortcut did we learn yesterday?
Just put the top one.
Cancel the 25s and keep this fraction. 24/7. You did something clever today.
You were just proving what Austin said, right?
Yes. He had it. He knew right where I was going.
Yeah.
He remembered that identity from back
We
when
don't
we...
need to like do all that jazz, you can just take, like,
Oh, yeah. Just look at them and write it down. Yeah, I'm fine with that. Okay, one more where we...
Wait, you take the numerators of both, right?
Yep, the two numerators.
Sine over cosine.
Sines numerator over cosines numerator. The denominators are going to cancel out when you flip and multiply. Okay, one more where here, notice the difference between these. Here I gave you information about the single angle and asked for all the double angles. Now I'm going to reverse it. I'm going to give you information about the double angle and ask for all of the single angles. So when you get to the notes or the homework, make sure you pay attention to which kind of problem you're doing. And this is it.
It's about the same one I was last.
Yep. So number 4, and this is it. I'm going to give you, okay. Find all 6 values of theta if cosine of 2 theta equals 3/4 and theta is in quadrant 3. Okay. Yep, I'm going to wait for you to write that down. I want you to pay attention to the difference between the one we just did and what we're going to do. Okay. When we just got done doing, I wanted all 6 trig values for 2 theta. So I wrote them all down to the side, off to the side. This one, I want all 6 values of theta. So that means I want sine of theta, cosine of theta, tangent of theta, and then all the reciprocals. Cosecant of theta, secant of theta, and cotangent of theta. All right. And what did I give you information about? I gave you information about 2 theta. So this time, starting with a triangle is not going to help me because I don't know anything about theta. What I can do, though, is start with an identity. Because I know cosine of 2 theta equals these 3 different things. The only one I would not want to use in this case is this one because it has 2 unknowns in it. Because I know this. I gave it to you. It's 3/4. But if I set it equal to, say, this one, I'll be able to figure out what sine of theta is. Or if I set it equal to this one, I can figure out what cosine of theta is. So you have to use one of these 2. You cannot use this first one. Which one's easier? Neither one's any easier than the other one. So what would you rather use? Doesn't matter.
1 minus 2 sine.
All right, so we'll go with 1 minus 2 sine squared. So I'm going to write down the identity. We know that the cosine of 2 theta, yep, we will after this. We cannot start with a triangle. Okay, so what I know this value. What is the cosine of 2 theta?
3/4.
It is equal to 3/4. That leaves us with the sine theta that we can solve for. So I'm just going to solve for the sine of theta. What's my first algebra step? Subtract 1. Subtract, can I make it 4/4? What's 3/4 minus 4/4?
Negative 1/4.
Negative 1/4. Equals a negative 2 sine squared. Now what?
Divide by negative 2.
divide by negative 2. What's the same thing as dividing by a negative 2? Multiplying by a negative 1/2. What are we going to have over here? 1/8. Positive equals sine squared. Square root. Top and bottom separate. So if I take the square root of 1 and the square root of 8,
What in the hell are
I will have sine.
Oh my god, I can't copy that.
Okay, what is the square root of 1? 1. And the square root of 8 is 2 square root of 2. And we can't leave that square root in the bottom. Close, square root of 2 over 4. Because, okay. So it took a lot of work to get to the sine of theta.
Why would it be a 4?
Because if this, cover up that 2, what's the square root of 2 times square root of 2?
2, 1, 2, 2.
2.
2.
And then you multiply by the 2 that's there. Square root of 2 times square root of 2 is
2. Square root of 4, so it's 2.
times 2.
Okay, I lost.
See it? If you just multiply that times that, that turns into 2. But then there is times by another 2 down there.
4.
4.
Hold on.
So that's our sine of theta. Now I know...
Wait, can you just wait, please? I'm trying to comprehend this and write it down at the same time.
Shouldn't that be negative though?
Oh, I forgot quadrant. Yes, what quadrant is theta in? Oh, because right here it's plus or minus. Good catch, Matt. What should it be?
Negative.
Negative because
In quadrant 3.
the theta is in quadrant 3. And sine in quadrant 3 is negative. Good catch. Okay, when I go to do secant now, I'm going to be clever and flip this thing over right here. Because when I flip this over, before I hit it with the 1, that's going to bring the square root to the top, and I won't have to hit it with the 1 again. So that means the cosecant will be negative 2 square root of 2. Otherwise, I take this, flip it over, hit it with a 1, do some simplifying, and I'm right back to what I just got. Okay, now that I know something about theta, now I can sketch a triangle and get the other ones from the triangle. So, let's do the triangle, then I'll show you what we did in both of them. So, quadrant 3. This is angle theta. I know this sine ratio is negative square root of 2 over 4. And then we got to find the negative x value. Putting my negative down right off the bat. So it's going to be x squared plus that negative square root of 2 squared equals 4 squared. We're going to have square root of 14.
Yep.
And now we can get all of our ratios from that.
Oh, no, this is square root of 14.
Mm-hmm. And now it's just a matter of using the triangle to fill in the other 4 values. So you ready for that? So cosine is negative square root of 14 over 4. Which makes, so we got to do a little bit, hit it with a 1 here. Can you flip it over and hit it with a 1 all in your head?
Yeah.
Yeah.
What's it going to be?
14.
4 square root.
4 square root of 14 over 14.
No. Negative 4
I think she's right.
14. No. over 14, but then you have to simplify.
Yep, then you gotta simplify. So it'd be 4 square root of 14 over 14 and a negative, but then the 4 and the 14 reduce each other. So we'll get negative 2 square root of 14 over 7. And then tangent, square root of 2 over square root of 14. I can reduce first and get square root of 1 over square root of 7. That's legal. Square root of 7 over 7.
Cotangent's just square root of 2.
After you do all the flipping, and it's going to be square root of 7.
All right, can you show me example 3 again, please?
Okay, now,
No, never mind.
with I do want to point out the difference. If you start with theta,
Okay, wait, no, time out first.
I want to say this first, and then you ask. Okay, so everybody else can get full. If you start out with theta, you sketch a triangle. First thing you want to do is a triangle. Then use your identities. So first triangle, second is identities.
First.
What? The second kind we had, I started with 2 theta information. So we first start with identities. Second is the triangle. So pay attention to what information you're starting with. Okay, Lexi, ask.
On example 3, when you wrote down all of the cosine and 2 theta, whatever,
Mm-hmm.
you put secant before cosecant?
I know that's because I wrote cosine first. I normally don't do that.
Okay.
Usually we write sine, cosine, tangent, but here I wrote cosine first, so I just wanted to match it.
Because you stressed me out.
Okay, sorry.
Wait,
Like example
wait, leave the
3.
answers up there now, 'cause I feel like mine's all messed up.
Okay, I'll put that there. Your homework.
No, not that one, the other one.
Oh, the 3 you want?
Yeah.
Okay.
Okay, there's 3. I don't know what part of 3 you want to see. What's today, Tuesday?
Yep.
We're in Trig, over here, page 223. 5, 7, 10, 13, 15. And I want to double check everything, or kind of give you a hint on which way to start them. So number 5. Okay, number 5 is just like example 3. This is like example 3. Seven is like example 4. Ten is like example 4.
Are these all finding this?
No. Let me double check, make sure. Oh God, I think I wrote them down wrong. Yep. Let's see. I looked at the wrong thing. I'm starting with the double information. That's 4. I got to flip-flop. This is 4. 7, I'm starting with the single. That's 3. 10, I am starting with the single. That's 3. And then it goes into, so there's 3 like these last 2, and then 13 and 15 are like some of the other ones. Those are quick.
So it's 4, 3, 3. Yes.
Thank you.
Oh, I want to add one more here, 38. 38.
Do you want to come check my homework?
You can come up here and show it to me. So these first 3 you're looking for, look at the way they say it. It's so ugly. If you just went to number 5, look at what it says. It says x, given cosine of 2x equals this, and it tells me that x is in quadrant This is a quadrant here from pi over 2 to pi is quadrant 2. But what they want is all 6 trig values of x. 7 is all 6 trig values of 2 theta. I just don't like the way they did these directions. They're just bad. If I could, I would. Okay. We just got done. Well, let me turn off my thing, though, so we don't...